Good morning, good evening. Thank you for listening. This is a medical show. I respect the law and I hope you do too. The topics and discussions today are for educational and scientific purposes, and the information is fact-checked. Any papers or websites that have been gone through will be put into discussion below for you to peruse later. And at the moment, it's an open topic. So I'll wait for the viewers to come in and ask some questions, hopefully, or some discussion topics, and that will give today's headline, or what is in the description below, or the description, sorry, below. It's above actually, or it'll be into week 2 of soil fertilizers and soil health. So that's what's going to happen. So I'll let the audience drive what's going to happen today to make the topic. So if you're rewatching this back, fast forward to you see the screen change till you see the slides come up. And that's a good indication that it's started. Because until then, it's just a lot of ramble. And I'll give another 40 seconds. And then it'll be 2 minutes. And then I'll have to think about something to say. We've got 20 seconds more to go. Looks like it's going to be straight into that course. The slides from that, I think, because there's no one even here yet. 5 more seconds. Bing, 2 minutes. So there's no one here yet, so I'm just going to start, and I can't ask for any words to be written because there's only one person actually. So I'll get straight into the slides. So share screen. Already, so that was last week. Importance of soil nutrient management. And today it's nitrogen and nitrogen for plant nutrition. That's going to be what's happening. So, nitrogen. Nitrogen exists in many forms in the environment, like there's a good 10 odd. And the plant only recognizes 2. So I'm not going to go through, and because this is an extremely detailed university course, so I'm just going to skim it. So that's nitrogen, and it's the most important nutrient for plant growth, making up 1.5% of its growth requirements. It's also important for yield quality and the environment as well. It's a key component of amino acids, protein, and chlorophyll. And 78% of the atmospheric gas is composed of dinitrogen, which may be converted to ammonium or nitrate forms to make it plant available. So there are 2 forms that the plant recognizes out of the 10 odd that there are. And he discovered the pathway. Very good. Basic nitrogen processes in soil plant system. So there's nitrogen soil processes, nitrogen gains and losses. So the nitrogen soil processes are mineralization. So how does it get nitrogen? So it can either be in mineral form, so you can just give it its urea or ammonia, whatever you feed it. Nitrification can happen, so through lightning or through microbes, and immobilization, where it's bound up in organic matter and then it's broken down into plant available form of nitrogen. The nitrogen gains. So how does it gain nitrogen? From biological nitrogen fixation through nitrogen fixating microbes, or fertilization, or organic additions. So you can add different alfalfa meal or kelp, different things that contain nitrogen is going to break down. And the losses is heaps. So the crop removes it out of the soil or your substrate. It leaches, so it goes through the water drainage and can leach out. See how it's got the negative anion, so it's not bound up as a cation because substrates usually have a slight negative charge. So this having a negative charge, it's easily leached out, where ammonia isn't because it's got the positive up there, so it kind of chelates or locks on. Another nitrogen loss form out of the substrate is denitrification. So microbes can change your nitrate into nitrogen gas like they do in wastewater treatment plants. They've got quite a lot of denitrification microbes. Or it can be volatilized off, so ammonia loss from the soil surface with water potential, or erosion. There's the nitrogen cycle. So it's how it cycles around. So plants can add to it and draw from it. What else we got around here? The atmosphere turns, and the root nodules of this rhizobium fix the nitrogen in there, or nitrosomes. Is it nitrosomes? Changes it from the, creates nitrogen out of the atmosphere. What does azose do? Azotobacter or azospirillum. That'll do for that. Actually, I should stop and see if anyone's arrived yet. No. That's the first time actually live. Hello, hello. Yes, he's live. Okay. Weird. Biological nitrogen fixation. So it can be symbiotic or non-symbiotic. Symbiotic means you've got to get rhizobium, really, and that's only good for legumes. But non-symbiotic is your azose, and that's the one that is good with any plant, and it's even good just in the soil itself because it can convert and leave it in the soil. It doesn't have to be symbiotic with any type of thing because it's a free-living bacteria. There's some math. Non-biological fixations. No. Atmospheric additions. So you can get, or your pollutants can come in, your nitrogen oxides and your sulfur dioxides are released. And they mix in. There's some industrial ways to produce ammonia. That's how they create the fertilizers, like it comes out of lightning, same way. Forms of soil nitrogen. Look at them all. So it's 1, 2, 3, 4, 5, 6. Where's nitrous oxide? Sorry, yeah. Thought there's a lot more than that. Organic form of soil nitrogen. Oh, they're bound up. I'm sure. Anyway, that's what it says in the slide. Transformation of organic nitrogen. So mineralization or immobilization. Which one? Well, mineralization, it's already mineralized, or immobile, it's immobile, bound up in something. So it's got to be released. So how can it be released? Usually by soil microbes. Recall. Both mineralization and immobilization are accelerated by conditions favorable for microbial growth, such as moist soil, warm temperatures, good aeration, easily degradable organic substrate material, physical mixing of soil via tillage, and higher soil pH. So not in the below 5s, because that's acidophiles and there's not much other microbes that grow below 5. Mineralization to the CN ratio. Well, a high mineralization ratio, where is it? So if it's really high, if you're going to make your compost or add this as a amendment, if you've got the first number too high, it'll break down too slow. And if you've got the first number too low, like here, it'll break down too fast. So you want your end product to contain a good amount of nitrogen. So that's why this CN ratio is important. And believe it or not, alfalfa has a perfect CN ratio. What about 23 or 24 to 1 is perfect for microbes. Here's the CN ratio. So finish, look at that, mature alfalfa hay is 25, so it's absolutely perfect. So that's why growing alfalfa is a good cover crop, because it's perfect carbon to nitrogen ratio when mixed back in. Mineralization of organic nitrogen. This is going to get detailed. Nitrogen metabolization, nitrification. So biological oxidation of ammonia to nitrate is done through nitrosomes, and then nitrosomes creates two-step process where ammonium is converted to nitrite and then to nitrate by two autotrophic bacteria. So nitrosomes takes ammonium and converts it to nitrite, and then nitrobacter takes nitrite, there's two ammonium and oxygen, and converts to nitrate. So two very important microbes. Nitrification. We just talked about that. I'm going to talk about it again. As you can see, this goes into pretty good detail. It's one of the best courses I've done. Factors affecting nitrification. So as a general rule of thumb, the environmental factors favouring growth of most upland agricultural crop plants are those that also favour the activity of nitrifying bacteria. Factors affecting nitrification in the soil are ammonium, supply of ammonium. That's, well, okay, if there's too much ammonium, azos aren't going to work that well. So that's why organics is good, because if azos are if they've got enough ammonium, they won't produce it. Population of nitrifying organisms, soil reaction, soil aeration, soil moisture, and temperature are the factors that affect nitrification in soil. Environmental factors. This goes into pretty good detail. I don't want to go into that much detail. The temperature is pretty interesting, because the optimum temperature for nitrification is around 90 F. 90 F, it's about 33 Celsius. And below 50 F, which is 10 Celsius, it slows rapidly. But nitrification still continues until freezing. But it's just extreme, like it's at about 10% when it gets down to that level. So that's why between 10 and 50F and 90F, or 10F and 33F Celsius, are the optimum for the microbial processes. For our mesophilic style microbes that we use, nitrification is regulated by abiotic conditions. When conditions are ideal, okay, good. This is pretty excellent. If you're going to remember one thing out of this whole thing, this is the chart to remember. So soil temperature versus nitrification. So remember I was saying before, you still get 10% about. At 50, well, it's 20%. But you can see it's 100% up about, what's that? 62, 5, 79. So it's 80 F, which is about 28 Fahrenheit, 28 Celsius. So between 28 is optimum for nitrification to happen. And below 50 F, or 10 Celsius, it slows rapidly. You can only expect 20% of the possible net outcome that you could get. Reductions in nitrification based on temperature. Yes. Or you can see if that temperature stays at a duration, it goes down even further. So that's all that's really going on. The x-axis is the time, y-axis is the actual process in percentage. Influence on tillage of organic nitrogen. So we'd have to know what this is. So we can talk about that. Sedimentary organic matter. There's a bit of a cycle. How it cycles around. I should see if there's any fair income. Be the first show with no one here. It's going live, yep. Loss of soil nitrogen. Talked about those before. Stages in a nitrogen cycle. Immobilization, talked about that. Levels of nitrogen available to plants based on microbial decomposition. So it depends on the carbon and nitrogen ratio. Because if you haven't got it right, you're not going to get a good nitrogen deposit after everything's broken down. That's what that basically says. Denitrification. So they're the ones that you don't want, because they'll take the good forms and create it back to the volatilization and gets evaporated through the air. So they're the ones that are in wastewater treatment plants. Denitrification. You want to add the oxygen. You want it to be oxygenized to be nitrified. Not denitrification loss with temperature again. You can see it's quite substantial. It's pretty technical. Atmospheric. It's pretty cool though. Just how it's got to go that high to go to nitrous oxide to get ozone effects. The troposphere goes to about 7 kilometers up, 5 miles or something. That's most storms don't go into the stratosphere. About 10k, that's where they fly. Remove from harvesting. Factors controlling nitrogen emissions. So temperature, changes in carbon, changes in oxygen through rainfall, groundwater, and organic carbon inputs, and rapid changes in nitrogen through fertilization and manure, grazing, and residues. Irrigation, soil moisture, and fertilizer of soils. Irrigation. Depending what form of nitrogen it is. Oh, it says it there. Nitrite. Ammonia volatilization, no. Nitrogen leaching. This is just the technical bit about it. How it leaches if it's more so nitrate, not ammonia. Eutrophication. This is what happens when it leaches out. If you see water streams or dams, ponds, lakes, anything like that, looking like this, that's because too much fertilizer has run into it. And in the form of nitrogen or phosphorus. So they'd have to add denitrification bacteria in there for that to make it clean again. Because it kills all the oxygen off. All the algae grows and uses up all the oxygen, and it kills off all of the oxygen in the water, and therefore the fish can't survive. There's a big plume of it. It's terrible. And sunlight blocks because of the algae too. It doesn't cycle. Factors with their degree of influence. Mechanisms of nitrogen. Not going to go into there. It's pretty good detail. Reactive nitrogen. Environmental problems associated with nitrogen fertilizer use. Methahemoglobia. Just all different problems you can get from the fertilizers. That's why organics is the go. All types of problems. There's even the eutrophication. They found that some of the spores were getting ingested into people's lungs and was causing a not carcinogenic, but some disease. That's in Australia too. Plant and uptake. So nitrogen is removed from the soil or substrate when it is taken up by the plants. These are the forms that it's recognized: nitrate, ammonia, and ammonium. Ammonia is the gas. That's the smell that you get. You'll recognize that from if you're in Canada, and if you're out walking, and if you smell ammonia, they put that in the, they put sulfur dioxide, rotten egg smell. That's right, it's sulfur dioxide. So if you smell that when you're walking, that means there's a gas leak, because they put it in their gas lines. Some estimated amounts of usage of nitrogen. It's very technical. Nitrogen inputs, including fertilizer and natural processes. Okay, this is just a bit of a cycle. How nitrogen cycles in and out, which we've already talked about. You can see it's pretty recent, 2021. Calculating nitrogen use efficiency, very important. I was doing that with my veggies. Actually, there's some garlic, and using the formula and going off chook manure. Turns out that the major supply here, which everybody uses and they've overtaken, they've got bad chook manure. If you get chook manure, it's called a blended mix. That means they blended it. It's not, you can't go off the math for what it is because it failed. I had nitrogen deficiencies bad, and I'm thinking, what? I added a good amount, added the proper amount as for the maths. No, because my source wasn't reliable. It was called a blended blooming mix, and yeah, because it's really good if you want to. No, I won't go into that bit, working out the nitrogen use efficiency. But all these different use efficiencies are very important if you want to minimize your inputs and outputs, so everything just flows well. Look at them all. Nitrogen use efficiency terms and calculations. I'm not going to go through any of them unless you really want me to. There's no one in chat, so it looks like you don't want me to. So they're pretty important, just to dialing things in. Then it goes into some maths. So calculating the nitrogen use efficiency. That's what I went and did. We are concerned about using some examples of what the outputs were. Relation between nitrogen and the yield. Nitrogen deficiency. It's a pretty overall yellow. You can see in this corn plant. And remember, nitrogen is a mobile element, so it is in the older shoots as well as the newer shoots. So it's the whole plant looks pale to yellow-green. Leaves start to wither and dry. It leaves the vein on the inside green, which is a pretty telltale sign because it's the opposite of potassium. Import nitrogen deficiency in plants. Nitrogen deficiency is common. It's immobile. Nitrogen uptake may be reduced at low pH. Sources of nitrogenous fertilizers. Well, I only want to talk about the immobilized organic fertilizers, because you can see here from the mineralized fertilizer, there's a lot. They blend them and mix them with this and that, and they all got different nitrogen contents. Look at this one here, 82%. 82% nitrogen. So that would burn most crops. See, I can dilute that a lot. But yeah, they got quite a lot of it. Flow chart for nitrogen fertilizers. Oh yeah, they got the different names on what they are commonly called over here, and what they're made up of, and how they start. General characteristics. Ammonia readily soluble in water. Much more resistant to leaching, ammonia, because it's a positive cation. are acidic in their residual effect. What's this? Equivalent acidity. The amount of calcium carbonate required to neutralize the acidity development. Oh, wow. Developed in 100 kilos of fertilizer. Jeez. See? Nitrate. Well, it's a negative anion, so it's easily lodged out with water. Highly mobile, very prone to leaching, prone to denitrification loss under poor water management. Oh, the equivalent. Okay, the equivalent for that. Okay, it's only a lot less. Ammonia and nitrate equivalency. Amine. Okay, this is getting into the different ones. Strategies to enhance nitrogen use efficiency. The right method of nitrogen applications. Deep placement of your green chlorophyll substance, because otherwise it leaches out. It gets in the tops and it can't be remineralized back into the soil because it's volatile when it goes up. So that's why if you get with your nitrogen, you want to bury it. What's the strategies to enhance? The color chart. I made a color chart and a chlorophyll meter. Oh, I'm not going to show it. No one's in. Strategies to enhance nitrogen use efficiency. Slow controlled release. Yes. This is more so for the persons that, well, neem is a organic input, and that's starting to become available in Australia. It's expensive of course, but it's starting to become available. That's just, neem-coated urea. Okay. Neem is a good source of nitrogen. It's about similar to chook poo. It's about a 5:2:1, something like that. So forget the last bit. Right method for nitrogen application. So this is talking about your fertilizer with granulized fertilizer. So you can get that with neem as well. They come in pellet form. So you'd want to bury that a little bit so the nitrogen isn't lost. You can get the benefits out of the whole thing. It's just a bit finer. See, the finer stuff, it doesn't last as long. That's the only difference with your granulized or inputs. So if you want fertilizer to last a lot longer, make sure you get grains that are bigger. Some case studies to prove it. Foliar applications in nitrogen works very, very well. Maybe about 100 ppm at the most. So you might get some, this is where you probably have to use mineralized fertilizer. I've got ammonium sulfate. But I don't like the sulfate bit because that's sulfur turns into sulfur dioxide, and it's acid form, which lowers the pH. So consider those things. But still, you make up 50 or 100 ppm and spray it on, and you'll see it quite happen fast. A deficiency with nitrogen. The disadvantages of foliar, yeah, it can wash out, so you've got to choose your time when you put it on. And not even heavy rainfall, just rainfall enough to drop it on and to take it off. Site-specific nutrient management. So you want prescriptive, corrective, okay. Here's the leaf chart. So see all it is just how green it is, and you can write on how deficient it is underneath and how you remedy it. So if all of that in the field was looking at that percent, which is all right, but it might just be under hidden hunger. So you might think, oh, I might have to put a little bit more in next time, or quickly do put the next few days' work might be a top dress program. going around doing a nice top dress to try and boost those up. So in a week's time, you'd expect that score to be not under 4, you'd expect it to be maybe 6, 7, which is nicer. So it's going to retain a lot more nutrients, a lot less has to be pulled out of the plant. Out of its sink cells, chlorophyll meter. Never used one of those. Can't really speak about it. But it's a good asset if you want to, if you're not familiar with using, like if you're colorblind, it might be a good excuse to use the chlorophyll meter. Slow and controlled release fertilizer. Well, that's just about the size of the granule. Nitrification inhibitor. So you can get some stuff that slows down nitrification process by adding another chemical in. And I don't really like that because you're adding more chemicals. So you want it to be as healthy as possible. You know, the CH4 oxidation to be in your soil if it doesn't have to be. There's a case study, neem coated. You know, you should just use neem itself, neem oil, neem cakes, nimin, which is neem seed kernel extract. Nimin, funny, eh? And the main, I'm not going to talk about neem, but it's got a lot high amount of nitrogen in it. I'm just going to check the ratio actually, because it's just here for my maths. Oh, you're kidding, it's not on that page. Oh, there it is. Neem, yeah. 5 is to 1.5 is to 2. So it's pretty close. Where a chicken poo is 5 is to 2 is to 1. Alfalfa meal is 2.5 is to 1 is to 2.5. And that'll do. Yeah, I'll throw in cow manure. 0.35 to 0.12 to 0.17 cow manure. And you know how good cow manure is for people? So if it's that low in numbers, you know that if you get sourced something a little bit more higher, like chook poo or neem or even alfalfa meal, you can have great results. Integrated nutrient management. So integrated nutrient management with nitrogen. So advantage is you might mitigate the ill effect of over reuse of synthetic fertilizers, definitely, because nitrogen loss is minimalized and soil health is well maintained. And a disadvantage might be lack of proper knowledge, which can result in a negative effect. What's this roadmap? Traditional agricultural practices, improved agricultural practices, plant breeding with nitrogen, beneficial fixation with nitrogen, and soil nitrogen cycling. So that's what should have been covered generally here, with me skimming over the top. Future scope of research for breeding strategies should be adopted to develop new nitrogen use efficiency varieties. Modern tools like remote and proximal sensor, GIS, decision support system, precision farming technology needs to be fine-tuned, and low-cost technology for manufacturing controlled release products need to be developed. Yes, they've got a press that you can use, a pellet press it's called, and you get your biomass and you put it through a pellet press, so you grind it up, put it through a pellet press, and it presses out those pellets. You make the different sizes for your release. And that's it. Thanks, everyone. If you're 5 people watching, I don't know what else to say because there hasn't been any comments today. I wonder if comments was turned off for some reason. That happens sometimes. Actually, let's have a look. There we go. G'day. What else can I talk about? I think I've been through all of them. So that was week 2. I'll share the screen. Already pressed that button. This one. So if I go back to this one, this is what I did last week and this week. So next week, potassium and phosphorus. And the week after will be the secondary minerals. Yeah, because this is the most informative class that I've done, and the most fine-tuned and on-point class that I've done. It was a full 12 weeks, so you can see week 12 there. Just should go and get all those. See if I can get those slides for that. And lost my train of thought. Week 12. Yeah, I wonder what's under this one. Oh, this is just all the spoken words. Oh. Okay, very good. So that's about it. I don't have much else to say. It would have been good to go through a few nitrogen questions or fine-tune nitrogen or anything like that to know which areas I could have focused on, but that was a good overall nitrogen discussion. Thanks. So I'm going to have to end it, I think. Everyone's been a bit quiet today. That's all right. At least the show happened. So I hope you're all enjoying the cricket like I am, and enjoy your day and your weekend. So happy breeding, happy growing, and good health to you all. Bye-bye.